Assalamu alaikum to all of you. This is abbasi here. Today we will discuss the chapter that is energy changes. Bismillahirrahmanirrahim. These are the topics which we have covered in our last lecture, that we discussed the exothermic reactions, definition of exothermic reactions, examples, characteristics of the exothermic reactions. Then we have also discussed the endothermic reactions, examples of the endothermic reactions. Then we have also discussed the characteristics of the endothermic reactions. Then at the end, comparison between exo and endothermic reactions, and last we discussed the plenary also. So this was the content, or this was the learning objectives of our last class. Now today we will discuss these learning objectives, like enthalpy change, energy level diagrams. Then we will discuss some questions, activation energy, energy profile diagram. These are two very important topics. Number one, energy level diagram and energy profile diagram. Some questions we will discuss. Then bond breaking and bond making. Last, how can we tell whether the reaction is endo or exothermic reactions on the basis of the calculation. Then we will also solve some questions. So let's look at today's topic. These topics which we have covered in our last class. So today we will move towards our new topic, that is the energy change or enthalpy change. Enthalpy change is basically represented by delta H, and definition for the enthalpy change is that the difference in energy content, amount of energy of the reactants and products in any chemical reaction. Say suppose we have discussed endo and exothermic reactions. For example, we discuss endothermic reaction. In endothermic reaction, heat energy is absorbed by the reactants. So when reactant react to produce product, then what will happen? Products will have more energy as compared to reactants, because they have absorbed the energy. So that in endothermic reaction, delta H will be in positive value. However, when we compare this with the exothermic reactions, in exothermic reactions, heat energy is released to the surrounding. So reactant react with one another to produce product. What will happen? Product will have less energy as compared to reactant, because heat energy was released to the surrounding. So here in exothermic reaction, delta H will be in negative. Now we are moving towards our delta H formula. What is the main formula related to this delta H enthalpy change? This is the formula. Delta H will be equal to total energy of the products minus total energy of the reactants. So from this equation we can derive these two main points. Number one, for endothermic reaction, delta H will be greater than 0. If it is greater than 0, means it will be in positive value. And for exothermic reaction, delta H will be less than 0. Less than 0 means it must be in negative value. Now the next topic is energy level diagrams. In energy level diagrams of the endo or exothermic reactions, you people have to draw these three very important points. Number one, you have to mention the reactant, you have to mention the product, and then you have to mention the delta H also. And this is the energy level diagram. So this side will be energy in joules, and this side will be time in second or minutes. Similarly, this will be the energy and this will be the time. This is vertical and this is horizontal. Products, reactants, and delta H. So in this energy level diagram, we have to explain these three main terms. So let's look at to discuss the exothermic reaction. In exothermic reaction, as you know, that heat energy is released to the surrounding, so product will have less energy as compared to reactant. So look at here, reactants has more energy, product have less energy, because heat energy is released to the surrounding, so that is the reason it is moving downward. Energy is content of energy is decreased, so that delta H will be in negative value. When we compare this with this endothermic reaction, so reactant react with one another, heat energy is absorbed, so this is moving in upward direction, means that energy is increased. That is the reason product have more energy as compared to reactants, and as a result delta H will become in positive value. So this was the energy level diagram for the endothermic reaction and exothermic reaction. Here we have explained the reactants, where where is the place of the reactant, where is the place of the product, and what about delta H, the value of delta H, whether it will be positive or negative. Now we are moving towards another topic, that is activation energy. What is the definition of the activation energy? It is the minimum amount of energy that reactant particles must possess in order for a chemical reaction to occur. If there is a chemical reaction happening in any substances, then we can say that those reactants are having activation energy, means they have the minimum amount of energy possessed by the reactant particles, then that reaction will proceed. So on the basis of the definition, we can deduce the two main points. Number one is that a chemical reaction will occur only when the reactant particles possess the energy equal or more than that the activation energy. If the activation energy is possessed by the reactant particles, there will be chemical reaction. If the second point is that if the reactant particles do not possess the activation energy, if it is less than activation energy, then what will happen? There will be no reaction. So this was a concept related to activation energy. Now we are discussing the another point related to activation energy for better understanding of the topic. An analogy for activation energy is an energy barrier is the game of volleyball. The volleyball means reactants must give sufficient energy in order for it to go over the net energy barrier. Say suppose you are giving enough amount of energy to this volleyball means reactant, then what will happen? It will move to this side, another court, means this is the complete reaction. If you are supplying less energy, then what will happen? It will move into our court, then what will happen? There will be no reaction. This is what the activation energy, concept of activation energy, means enough amount of the energy possessed by the reactant particles, then they will proceed for the reaction. So this was a concept related to activation energy. Now we are moving towards another very important topic that I have mentioned in the learning objectives, that is energy profile diagrams. In energy profile diagrams of the endothermic and exothermic, when you compare energy level and energy profile, so there is only one change, that in energy profile we are also highlighting the activation energy. This is the only one main difference when you compare energy level and energy profile diagram. The rest of other, that will be the same. Now reactants, this is exothermic reaction. Reactants are here, they will release the heat energy and then products will be produced. So this will be called as the delta H, change in heat energy, enthalpy change. And this is they must have the activation energy for the reaction to proceed. So this is the area for the activation energy of the exothermic reaction. Then this is endothermic reaction. In this endothermic reactions, reactant react with one another to form product. So reactant the energy will be absorbed here. So then what will happen, products will be produced and product will have more energy. So this is the activation energy in endothermic reaction, and then this is the delta H change in enthalpy. So this is the diagram of endo and exothermic reaction, and that is energy profile diagram. And in the question, in the exam, how they will give any reaction, and then they will say that draw the exothermic or endothermic reaction, and we have to write here the reactant. Say suppose hydrogen, oxygen, or any chemical reaction, just we have to now we have to write the reactants and products, then activation energy delta H, that will be same. So this is the way how to give the, you know, how to write the answer related to exo and endothermic reaction, and that will be related to energy profile diagrams. Now another very important concept, that bond breaking and bond making. As you know that when you break anything, you have to supply amount of heat energy. So bond breaking, when bonds between atoms are broken, heat energy must be absorbed from the surroundings. So if bond in bond breaking, heat energy is absorbed, so heat energy is absorbed in the endothermic reaction. So breaking, bond breaking is endothermic reaction, while the bond making is exo, because in bond making heat energy is released to the surrounding. If the heat energy is released to the surroundings means that must be exothermic reaction. So on this main two, you know, concepts, we can conclude this topic that bond breaking is endo, bond making is exothermic reaction. Now the last very important topic is that how can we tell whether the reaction is endothermic or exothermic reaction. It depends on the overall enthalpy change. If it is in positive, the reaction will be endo. If it is a negative, the reaction will be exothermic reaction. So now how can we calculate the overall enthalpy change, delta H? There is a formula. Look at this formula. Overall enthalpy change will be equal to total energy absorbed for bond breaking minus total energy released in bond formation. This is the main equation for the calculation of overall enthalpy change. Now on the basis of this formula, we can conclude two main points, that if energy absorbed in breaking bond is less than the energy given out in the bond making, the reaction will be exo, because energy released is greater. So look at here, total amount, total energy release, total energy absorbed for bond breaking is less than the total energy release, means total energy released will be greater, so the reaction will be exothermic. Now look at this another formula, that here total energy absorbed will be greater than the total energy released, so the answer will be in positive value. If the answer is in positive value, definitely the reaction will be endo. In this, if the heat energy absorbed in bond breaking is less than the heat energy absorbed, heat energy is released for bond formation, here the answer will be in negative value. If it is in negative value, you can say that reaction will be, overall answer will be in negative. Today we will prove this with the formula, then we can conclude that this reaction will be exothermic reaction. Now we are moving towards our example, which right now I told you that we can, here you have to balance it by 2. The example, reaction between hydrogen and oxygen to produce water. Hydrogen, oxygen, water, 2 moles of hydrogen, 1 mole of oxygen, it will produce 2 moles of water. Energy for hydrogen bond breaking is 436, oxygen 496, oxygen and hydrogen, that is 4633 kilojoule. Now we have to calculate by performing these 3 steps. Number 1, energy absorbed and bond breaking. So let's look at here. The bonds of in the hydrogen and oxygen molecules should first be broken before hydrogen and oxygen react to combine, and then they will produce water. So initially they must be broken. So this requires energy to be absorbed, means this will be the endothermic reaction. That is the reason that I have placed this heading, that energy absorbed and bond breaking means endothermic reaction. Energy required to break the bond between hydrogen and oxygen. Hydrogen, look at here, one hydrogen is 4, hydrogen is 436. So here the hydrogen moles are 2. So we will multiply 436 by 2. We will get 872 kilojoule energy of the hydrogen molecule. 2 moles of hydrogen molecule. Then for there is a one oxygen molecule, that is 496. Now you have to add these two values of the hydrogen and oxygen, like 872, 496. You will get 1368 kilojoule energy. That is for the bond breaking for endothermic reaction. Now we will calculate the second state, that is the energy release in bond making, that will be exothermic reaction. Now the bonds between hydrogen and oxygen atoms will combine to form new bonds, and this requires the energy to be released, and in this way we can say that is the exothermic reactions. Energy released forming 1 mole of OH bonds, that will be value for the OH bond is 463, and energy released in forming 2 moles of OH. 2 moles of OH will be equal to 1 mole of water. So 1 mole of water, but in the question look at here, here are the 2 moles of water. For the 1 mole of water, the energy will be, look at here, 926. So energy released on forming 2 moles of water, that will be equal to, multiply this by the 2, you will get 1852 answer for the option 2, heading 2, that is energy released in bond making. Now you have to put this these two values on the last overall heat energy, heat change, that is delta H will be equal to energy absorbed in bond breaking, that is 1368, energy released in for the bond formation, that is 1852. So the answer will be minus 484 kilojoule, means if the answer is in minus, negative, so definitely the overall reaction will be exothermic reaction. The negative value of the overall enthalpy change, means delta H, shows that the reaction between the hydrogen and oxygen to form water is exothermic reaction. So this is the exothermic reaction. I hope you understood this calculation of how to calculate whether the reaction is endo or exo. Thank you. Allah Hafiz.